Now, if we try to do the same analysis we did previously for this function, we're going to run into a problem. I'll show you what that problem is. Okay, the graph would have zeros, of course, at negative 1, 1, and 2. Now, if x is less than negative 1, you can verify that this is going to be positive. So it's going to have to come down from up here. And if you go to the right of 2, x value is greater than 2, we're going to make it positive. So it's going to go up this way. Now the y-intercept, if x is 0, you have negative 1 times 1 times negative 2 quantity squared. Well, that's negative 2. Okay? I'm sorry, negative 4. So you got to start up here. You got to go through this point, and through this point, and end up going upward in this end. Well, if I start from up here and come down through 1, and through this y-intercept and up here, and then come through this point, I end up going down, not up. But I know that I have to go up because I know that if x is bigger than 2, the thing has to be positive. It can't go negative. Okay, so what's the problem here? Well, as it turns out, I have a number of options for going through my zeros. Okay, so if I have a situation where I've got to go through these points, starting from here and ending, going up here, I could do this in a number of ways. I could come down through here, come up here, come down here, and go up. I don't have to go through this point. Now the problem, of course, is if I go through this point, then my values become positive and I have to stay positive until I get here. And then if I go through this point, my values are going to become negative and they can't become positive again because there are no more zeros to go through. Okay, so the graph could look like this, or it could look like this. Now, wait a minute, it can't look like this. Not if it's going to go through this point. Okay? So forget it, I don't have another alternative. Okay. If it's going to get down to here, it has to go through this one. Then it could either turn around at this point, or, well, actually I haven't drawn it. I mean, it's already on the board. Okay, so let's do it again. So I come down here, I could come up here, and then I could come down and turn around at this point. So I could do my turnaround here or here. Now, why would this function have a turnaround at one point or another, and at what point would it have a turnaround? Well, notice it. It's going to turn around at x equals 2, and I'll tell you why. Okay. Now, if x is 2, of course we know that f of x equals 0. But I want to write it this way. I'm going to write it as y equals 2 minus 1, 2 plus 1, but I'm not going to put the 2 in for this x. Of course, if I did, I would get 0. Okay, so I get y equals 2 minus 1 times 2 plus 1 times x minus 2 squared. And this multiplies out to 2. It's 1 times 2, it's 2. So now y is 2 times the quantity x minus 2 squared. Okay? Now, it's still 0 if x equals 2, but the point is now if x is just close to 2, then this isn't 0 anymore. And this isn't 1 anymore, and this isn't 2 anymore, so this isn't 2 anymore. But this is going to be close to 0, of course. X minus, if x is close to 2, x minus 2 is close to 0. But also, 2 minus 1 is still going to be close to 1. 2 plus 1 is still going to be close to 2. So this times this is still going to be close to 2. Excuse me. So if x is close to 2, not necessarily equal, but close to 2, then of course f of x, first of all, place is close to 0 because it's x minus 2. Also, x minus 1 times x plus 1 is still close to 2. So f of x is still close to 2 times x minus 2 squared. Okay? So your function close to the point 2, 0, close to the point where x equals 2, and that is the point 2, 0 on the graph, this point, is close to this function. And what's this function? Well, this function is just the y equals x squared graph, vertically stretched by factor 2 and horizontally shifted 2 units. So, we can sketch that. There's the y equals x squared parabola. Stretch it by factor 2, and the point 1, 1 becomes the point 1, 2, and the rest of the parabola stretches out. And then shift it 2 units to the right, the vertex moves to 2, 0, which is the point at which, that's one of our zeros of this function. And the point, 1, 2 would shift 2 units to the right. 1 would shift over to 3. We'd have 3, 2. Okay? So this would be the picture of this graph if you're very close to the point where x equals 2. And I did have a 2 here, but okay. Well, okay, let's just purple in the points on this parabola that are close to x equals 2, right there. Okay? And then I'm going to purple in a little parabola close to x equals 2 here, same parabola. And now I know that my function, whatever else it does, has to very closely agree with this some small section of this parabola close to 2. So I can draw my graph. Here are my zeros at -1, 1, and 2. I know that I'm up here. I know that I've got to go up here. So I come down through this one, and I go through my y-intercept, come back up through this one, and then I turn around and just dip down and kiss the x-axis at the point 2, 0. Okay? So the point 2, 0 is on my graph, and close to the point 2, 0, it behaves like the part of this parabola that's close to the point 2, 0. Okay. Now, I'll say a little bit more about constructing this graph, just to review some of the things we said previously.